Hello class, let's take a look at the introduction to section 9.2 and 9.3. So this is the basic idea in this section. We're going to be estimating some sort of a proportion, which is going to represent a percentage, or some sort of a population mean. And the main idea is that the value of sigma is actually given for any of these two scenarios. Now, what we're finding in this particular problem is just the critical values to estimate these two. The formulas will be given in the next section. And as we refer to the general sketch, we're basically looking at the following. So if we're estimating a proportion or some sort of a population mean, we're first assuming that this actual given value of sigma is in fact given. And these critical values, which are used in the formulas to estimate these parameters, are actually obtained from the normal distribution or from the t-distribution, which is technically its cousin. So let me go over example 1. So this is going to be the sketch that we're going to be actually doing as long as we're estimating proportions or means. And if we're estimating proportions and means, and we have the value of sigma, all of these are going to come from some sort of a bell-shaped curve. Now, within the bell-shaped curve, you're going to have the following regions. So this is going to be the level of C, and C is referred as the probability that we have the parameter, or the level of confidence. Now, you're also going to have the values of alpha. Alpha represents the value that we do not have the parameter. And from the sketch, this value here is going to represent the values of alpha divided by 2. This value here, it's going to represent the values of alpha divided by 2. And since you technically have a population, you're looking at the values of C plus alpha is equal to the values of 1. So this area plus that area plus that area, it's all equal to 1. And assuming that you're estimating a proportion or a mean and sigma is given, these values are going to be z-scores. Your critical value, it's going to be the actual z-score that happens to be on the right. So it's going to be a z-score that happens to be on the right hand side. Yet again, most of the times we're finding the one on the negative and then just basically transposing it to the positive side.